Welcome to this explainer. Let's get right into it. Today, we're handing busy executives the bottom line playbook on exactly why laser cutting is your 2026 mandate for driving down supply chain costs and boosting your agility. If you're managing global manufacturing contracts, whether we're talking bulk industrial components or agile private labels, you know the landscape is shifting fast. So let's break down how this technology actually maintains your competitive edge.
Okay, here's our roadmap for today. We're going to cover the 2026 mandate, bottom line impact, speed and consolidation, laser versus traditional methods, supplier evaluation, and finally, risk mitigation. Starting off with Section 1, the 2026 supply chain mandate. Look, as a procurement professional, you already know survival is all about absolute cost predictability. Laser cutting has really rapidly transitioned from being just a premium specialized service into a hard foundational requirement. Now, when you're evaluating quotes, it's dangerously easy to get hung up on that initial hourly machine rate. But as an executive, you've got to look past that surface level number and focus in on the total cost of ownership. The structural financial benefits of laser cutting fundamentally alter that whole equation. Moving right along to Section 2, impacting the bottom line. $0. That right there represents your tooling costs. For brand owners and e-commerce sellers, the absence of tooling costs is honestly an absolute game changer. There are literally no expensive custom dies to buy. What does that mean for you? It means you unlock incredibly low minimum order quantities. You can radically cheapen prototyping for OEM and ODM projects, meaning you can iterate on designs in the early stages without shelling out for a brand new mold every single time a dimension shifts by just a millimeter. And because there's no physical tool, your timeline completely transforms. Traditionally, custom die manufacturing holds your capital hostage for weeks. But with laser cutting, the tool is literally just a digital file. You move from uploading a CAD file in minutes to executing production runs almost instantly. Production starts the very second that file hits the machine. Now, it's a fundamental truth in procurement. Raw material costs are almost always the largest variable in a manufacturing quote. So if raw material is your biggest expense, then controlling your scrap rate is the ultimate hidden lever for protecting your margins. This brings us to nesting software. You can think of it kind of like an automated, high-stakes game of Tetris. The software arranges your parts on a sheet of metal to absolutely minimize scrap. Always ask your supplier about their nesting efficiency. A supplier boasting a 90% automated nesting efficiency is going to drastically lower your per unit price, even if their hourly machine rate looks higher than a competitor who's stuck at, say, 75%. That 15% material savings, that goes straight back to your bottom line. Section 3, speed, precision, and consolidation. So how exactly does the machinery pull off these financial wins? Let's reverse engineer it. Step 1 is extreme precision. We're talking tolerances under 0.1 millimeters. For you, this translates directly into fewer defective parts and much higher assembly yields. Step 2, laser cuts are burr-free. That means no expensive, labor-intensive secondary grinding to smooth things out. And step 3 is versatility. By combining that extreme tolerance with burr-free cuts across everything from carbon steel right down to acrylics, you get a retail-ready product while actively consolidating vendor bloat. Next up, Section 4, laser versus traditional methods. You know, every industrial cutting technology out there has a specific sweet spot, but comparing them side by side reveals a pretty clear winner for modern agility. Laser, plasma, and water jet all boast zero tooling costs, which is great, unlike the really heavy die costs associated with CNC punching. But when you start factoring in speed, especially for thin metals, fiber lasers absolutely dominate. Compare that to the massive heat-affected zones you get with plasma, or the sluggish speed of a water jet. For complex, high-precision parts, lasers just offer the best intersection of speed and cost. Section 5, evaluating high-performance suppliers. If you are heading out to audit a new factory for your 2026 supply chain, consider this your execution playbook. A supplier's equipment list directly reflects their capacity to meet your deadlines. First, check the wattage. You want to look for 6 to 20 kilowatt fiber lasers if you need to process thick plates and handle those urgent production spikes. For nonmetals, make sure they have capable CO2 lasers. And crucially, look for premium laser source brands, names like IPG, Enlight, or Trump. These top-tier brands guarantee better beam stability, which keeps your supply chain safe from unexpected, costly machine downtime. Another critical detail, you absolutely must specify the assist gas in your contracts, as it drastically impacts the final finish. Nitrogen cutting is essential for materials like stainless steel because it yields a clean, silver, weld-ready edge instantly. Oxygen cutting on carbon steel might be a bit faster, but the catch is that it leaves an oxide layer behind. That layer requires manual removal before you can do any powder coating. Knowing the difference here saves you from hidden secondary finishing costs down the line.
Now, for you high-volume bulk buyers, human labor is a notorious bottleneck. Enter lights-out manufacturing. This is the use of automated loading and unloading towers to enable 24-hour unattended production, literally running with the lights out. Partnering with a supplier capable of these shifts removes human bottlenecks entirely. It guarantees supply chain stability during your most aggressive peak seasons, all while driving down contract pricing.
And finally, Section 6, mitigating supply chain risks.
We all know there's always a catch, right? Every executive knows to look for it. So let's talk due diligence on 3 specific technical risks. First is the heat-affected zone, or HAZ. The laser's intense heat can actually alter the metal's edge properties, which is critical to audit if you're sourcing something like aerospace parts. Second, highly reflective metals like brass or copper can literally bounce the laser beam right back and damage the machine. You have to verify your supplier has back reflection protection. And third, dross. That's the hardened, molten metal that accumulates on the bottom edge of thick plates. Make absolutely sure your contracts set strict, quantifiable quality standards for acceptable dross.
I want to leave you with this provocative thought to take back to your teams. Is your current supplier network truly equipped for 2026 agility? Seriously, if your vendors are still charging you for custom dies, struggling with high scrap rates, or failing to offer 90% nesting efficiencies, you are leaving real money on the table. It's time to leverage the strategies we've covered in this explainer and proactively upgrade your supply chain. Thanks for joining me today, and here's to a much more efficient, cost-predictable future.